All right, compacted. This video ends all of your notes for Module 14. So hooray, you did it. All right, so the first part of our notes, this is our your turn. So thinking back to how we finished the first part of 14.3 video, we talked about how we ordered those numbers. We had 3 times pi, the square root of 10, and 3.25. Now you're going to do the same thing here with these two your turn questions, but in addition to ordering them from least to greatest, you're also going to plot them on the number line that's provided to you. So go ahead and pause the video and get started on those problems, and then you can check in with me to see how you did. All right, so number 3, we have the square root of 5, 2.5, and the square root of 3. So let's start with the square root of 5. The square root of 5 falls between the two perfect squares, 4 and 9. So the square root of 4 and the square root of 9. And now the square root of 4 is 2, and the square root of 9 is 3. And 5 is much closer to 4 than it is to 9. So in my approximate, I'm going to say that it is about 2.1. And then we've got 2.5. And now I'm going to find the square root of 3 by approximating that. And so the square root of 3, or 3, falls between the first two perfect squares in our list as 1 and 4. So the square root of 1 and the square root of 4. And the square root of 1 is 1. The square root of 4 is 2. 3 is much closer to 2 than it is, 3 is much closer to 4 than it is to 1. So we know that the square root of 3 is much closer to 2. So I'm going to approximate that about 1.8. So now we've got 2.1, which is the square root of 5, approximately, 2.5, and 1.8. Well, 1.8 is clearly much less, so the square root of 3 is the least value in our set. And then we have the square root of 5, which is that 2.1. And then we have 2.5. So now I'm going to plot those points. Well, 2.5 is right here. And then we have the square root of 5, which is just over 2, so about 2.1. And we'll label it as the square root of 5. And then we have that square root of 3, which is 1.8. Which is on the other side of 2. And the square root of 3 there. And then we're going to do the same thing with number 4, except here we have pi squared, 10, and the square root of 75. Well, pi squared, we know that pi is 3.14, so 3.14 squared, 3 squared is 9, so we know that 3.14 squared is going to be just a bit more than 9. So for right now, I'm just going to approximate it so I can go ahead on to the next numbers. So about 9 plus, right? We're going to say 9 plus for a little more than 9. And then we have our 10, and now let's focus on the square root of 75. So 75 falls between what two perfect squares in that list we had made? Well, it falls between 64 and 81. And the square root of 64 is 8. Square root of 81 is 9. And 75 is much closer to 81 than it is to 64, but it's real close to being in the middle. So as an approximate, I'm going to say about 8.7. So we've got a little bit more than 9, that's that pi squared. We've got 10, and we've got 8.7 about for the square root of 75. So listing this in order from least to greatest, the smallest is going to be that square root of 75. And then we've got pi squared. And then we've got 10. So plotting those on my number line, the smallest is going to be that square root of 75, which is about 8.7. So about in the middle of 8.5 and 9. And then we've got pi squared, a little bit more than 9. Pi squared, and then we've got 10. All right, let's look at example 3. The diameter of a meteorite in millimeters is calculated by 4 different methods. Order the results from least to greatest. So we've got Joe, who's found his to be the square root of 18 millimeters. Lisa, 13/3 millimeters. Pablo, 4.6 millimeters. And Julian, 4 pi over 3. So 4 pi divided by 3 millimeters. So let's start by simplifying those that we can. I'm going to start with Lisa because I know that 13/3 can be simplified to 4 1/3. And I know that that as a decimal is 4.3 repeating. So there I have Lisa's already in decimal form. Now I'm going to do the same with Julian. So 4 pi, I'm going to take 4 times my 3.14 over 3. Well, 4 times 3.14 comes out to be 12.56 divided by 3. And right now, without doing any real calculations, I can just do some estimating here. 12.56 is real close to 12.5. And I know that 3 times 4 is 12, so it goes in 4 even times with roughly 0.5 left over. Well, 0.5 over 3 can be simplified to 1/6. We can double it. So 4 1/6. And 4 1/6 as a decimal is 4.16. And then we've got Joe. So we've got the square root of 18. So we need to approximate that. So 18 falls between what two perfect squares? That would be 16 and 25. And the square root of 16 is 4, and the square root of 25 is 5. So in my approximate here, 18 is closer to 16 than it is to 25. So I'm going to say about 4.2. But now, as I look at my list, I've got Joe at about 4.2, Lisa at 4.3 repeating, Pablo 4.6, and Julian 4.16. Now keep in mind, both Julian and Joe's are approximated. Julian's because I just rounded that 12.56 to 12.5, and Joe because it is an irrational number, and so I am making an approximate. So right now, in this example, this is a time when I would check on my calculator just to see really which one is actually less than the other. So I'm going to take Joe, for example, and on my calculator, I'm going to take the square root, and you'll have to look at your calculator to find the key that is the square root button. So the square root of 18 on a calculator actually comes out to be 4.2426. So we did a pretty good job of estimating that to be 4.2. And then I'm going to check Julian's as well just to see how close that is, because again, if it's also 4.2, then we have to look at those next following digits. So 12.56 divided by 3 actually comes out to be 4.1866. So I can see here that my approximates were close, so now I could put them in order if I needed to, but for the sake of this problem, actually I lied. My last sentence actually does say to order the results from least to greatest, so we're going to go on with that. So looking at these from least to greatest, I can see that Julian, 4.16, or even in the actual answer being 4.1866, we would put that as the least value, but we're going to write it in the form that it was given. So 4 times pi over 3. And then the next greatest number from that is going to be Joe at 4.2. So square root of 18. And then we have 4.3 repeating, that's Lisa. So 13 thirds. And then we have Pablo, 4.6. All right, so your last and final problem here is this your turn. Very similar to example 3. 4 people have found the distance in miles across a crate using different methods. Their results are given below. Order the distances from least to greatest. So pause the video and do these problems. Again, refer to example 3 if you need any help, and then check your answers with me. All right, so let's get going. We've got Jonathan with 10 thirds. So I'm going to simplify that. Well, I know that 3 goes into 10 3 times with 1 left over, so 3 1/3, which shapes out to be 3.3 repeating as a decimal. And Elaine, we've already got that as 3.45 repeating. And then we have 3 1/2, which we can convert that to the decimal 3.5. So the first 3 are already in decimal form real quick for us. And now we have LaShonda, the square root of 10. Well, the square root of 10 falls between these two perfect squares. Square root of 9 and the square root of 16. Square root of 9 is 3, 16 is 4. 10 is much closer to 9 than it is to 16. So I'm going to approximate that as 3.1. So now, looking at my list, I've got 3.1 for LaShonda, 3.5 for Jose, 3.45 repeating for Elaine, and 3.3 repeating for Jonathan. So ordering these from least to greatest, LaShonda's is the least, so that's the square root of 10. And then we have Elaine, 3.45, repeating. And then we have Jose, 3.5 or 3.5. And actually, I realized that I've made a mistake because I forgot Jonathan in there. So actually, I had to pause for a minute and do some thinking because 3.3 is before Elaine. So actually, so sorry, hopefully you caught my error as I was making it. So we've got LaShonda, and then we have Jonathan. So 10/3. And then we've got Elaine. And then we've got Jose, 3.5. So there we have it. Now we have an accurate list in order from least to greatest.